Good afternoon, members. I'm back to our work. Mr. Fassos Ronald, taking you up in chemistry. Let us get out our notebooks and we continue from where we stopped. The other previous discussions we talked about acids, bases, and so other acids and bases. So we first discussed acids, then we came to bases and alkalis, and now we are going to discuss salts. Salts. What a salt is. Everybody of us know what to call a salt. At home you encounter with salt, you have different kinds of salts. So today we are going to learn what a salt is in particular and some different methods of preparing salts. So by definition, a salt is a substance. A salt is the substance consisting of positive metallic ions, positively metallic ions, and negatively derived and negative ion, positive metallic ions, and negative ions derived from acids, derived from acids. So therefore, a salt has got two parts. It has got a positive part. Salt has two parts. One part is the positive part. This positive part is what we call the cation, and it has got what we call a negative part. This negative part, negative part is the anion. The cation is the metallic ion, and the anion, this is the acid derivative. Or what we call acid radical. So that's what we can take about the salt. So by definition, a salt is defined as a substance formed when part or all ionizable hydrogen ions of the acid are replaced by a metallic ion or an ammonium radical. So by definition, that's how we define a salt. A compound formed when part or all the ionizable hydrogen ions of the acid being replaced by a metallic ion or ammonium radical. Remember that from our definitions of acids, we say that an acid is that substance which dissolves in water and produces hydrogen ions as the positively charged what? Ions. So once acids, for instance, sulfuric acid dissolves in ionizes, gives us hydrogen ions plus sulfate ions, aqueous. Okay? And then it can also undergo partial ionization. The sulfuric acid can also ionize in this form the hydrogen ion plus hydrogen sulfate ion. So once then plus the hydrogen sulfate ion. So once you bring in a base, for instance, sodium hydroxide solution, this will break to give us sodium ions and then plus hydroxide ions. So from our definition, a substance formed when part or all the ionizable hydrogen ions being replaced by a metallic ion. If we bring this solution to react with this acid, replacing all the hydrogen ions, means that this acid is going to attack the sodium hydroxide, in this case, to give you sodium sulfate solution plus water, meaning that all the ionizable hydrogen ions of the acid have been replaced by the sodium metal, meaning that that salt is formed when all ionizable hydrogen ions of the acid being replaced. Then there is also another case, this case sodium hydroxide plus sulfuric acid, you get sodium hydrogen sulfate and then plus water. So in this case, all the hydrogen ions have been replaced. It is just part which has been what? Replaced. But here, all have been what? Replaced. So that's where we get our definition of a salt. A substance formed when part or all the ionizable hydrogen ions of the acid being replaced by a metallic ion or an ammonium radical. And this one will bring to us the types of salts we have. The types of salts. Types of salts. Types of salts. Under the types of salts, we have what we call the normal and acidic salts. Normal and acidic salts. Let's begin with normal salts. Normal salts. How do we define a normal salt? All of them we get from replacing hydrogen ions of the acid by a metallic ion. So, for instance, sodium hydroxide is reacting with sulfuric acid, then we get sodium sulfate, aqueous, and then plus water. So our salt we have got is the sodium sulfate, and we say this salt is normal. Why is it normal? Because we are getting it from the acid, sulfuric acid, completely ionizing to give to hydrogen ions plus sulfate ions, meaning that the sodium hydroxide also splitted to give you sodium ions plus hydroxide ions. So the hydroxide ions attack the hydrogen ions. In this case, we got water, and then the sodium ions plus sulfate ions, we got sodium sulfate, meaning that this salt has been formed when all the ionizable hydrogen ions of the acid are being replaced by the metallic ion, that is of sodium. So when we define a normal salt first of all is the salt formed when all the ionizable hydrogen ions, all the ionizable hydrogen ions of the acid, ionizable hydrogen ions of the acid are being replaced, formed when all the ionizable hydrogen ions of the acid have been completely replaced by a metallic ion or an ammonium radical So I shall have a note, and we say all normal salts have no. All normal salts have no hydrogen atoms in their molecules. Have no hydrogen atoms in their molecules. Even though when they are dissolved in water, their solutions are always neutral to litmus papers. For example, examples include how you can have sodium chloride, copper 2 sulfate, how can have sodium sulfate, potassium nitrate. In other words, all nitrates and all chlorides and no more salts, and all nitrates, because they are acid derivatives. Their acids only produce one hydrogen ion per molecule of the acid. So meaning that acid has only one replaceable hydrogen ions that can be replaced by the metallic ion. Therefore, all the acids, nitric acid and the hydrochloric acid, all salts derived from those acids are all normal. And another category of salts, we come to the acid salts. An acid So this one comes from the term acid. That is the substance that will produce hydrogen ions when dissolved in water as the only positive charged ions. So when we say an acid is salt, that means that that salt has what we call hydrogen ions in its molecules. So we say one, the salts have hydrogen ions in hydrogen atoms in their molecules. And why do they have hydrogen atoms in their molecules? It is because these salts are formed. The salts are formed when part of the ionizable hydrogen ions of the acid have been replaced by a metallic ion or ammonium radical. So that's what we call an acid salt. First of all, the salt has hydrogen atoms in their molecules. Let us illustrate it here. For instance, sodium hydroxide plus sulfuric acid will get sodium hydrogen sulfate then plus water liquid. So if we compare it to sodium sulfate, sodium sulfate has no hydrogen atoms, and yet sodium hydrogen sulfate has hydrogen atoms in its molecules. So if the salt has hydrogen atoms in the molecules, once this salt is dissolved in water, its anion will yet undergo further ionization, producing hydrogen ions just like acid do. That's why they are said to be acidic salts. For instance, when I get sodium hydrogen sulfate plus aqueous, that when I dissolved it in water, this will give me sodium ions plus hydrogen sulfate ions. Because we have said that a salt has got two parts. It has a positive part and a negative part. So the positive part is the hydrogen part, that's the sodium ion. The negative part, the acid derivative, acid radical, which is the hydrogen sulfate ion. So for these acid salts, their ions can yet and anions can yet undergo ionization, which is not the same case to the normal salts. Their anions do not ionize in water. But if it was an acid salt, the anion can yet undergo further ionization in water to give you hydrogen ions, just like the acid does. That's why we call them acid salts. First of all, they contain hydrogen atoms. Why do they contain hydrogen atoms? Because they are formed when part of the ionizable hydrogen ions of the acid are being replaced by a metallic ion. So Those are some examples. Some examples of acid salts. Examples can have one, sodium hydrogen sulfate, sodium hydrogen carbonate, can have potassium hydrogen sulfate, potassium hydrogen carbonate, can have magnesium hydrogen carbonate, calcium hydrogen carbonate, there is calcium dihydrogen phosphate, and so on. So acids which form acid salts, one we have sulfuric acid and we have phosphoric acid. But nitric acid and hydrochloric acid, for them they only form normal salts because they have only one replaceable hydrogen ions. Sulfuric acid can form both normal and acid salts. Why? Because sulfuric acid produces two replaceable hydrogen ions. So once all those two replaceable hydrogen ions have been replaced completely, then the salt formed in the reaction will be normal. If part of those hydrogen ions have been replaced, then the salt formed in the reaction will be an acid salt. The same applies to phosphoric acid. It can also form a normal salt and it can form two acid salts. It can form hydrogen phosphate and a dihydrogen phosphate, because for it produces 3 replaceable hydrogen ions per molecule of the what? The acid. Then from there come to preparation of salts. Preparation of salts. Preparation of salts. A salt is prepared depending on whether the salt is the method of preparation of salts depends on 2 ways, on these 2 aspects. Method of preparation of a salt depends on whether the salt is 1. Soluble or insoluble. Depends on those 2 aspects. Whether the salt you are going to prepare is soluble in water or insoluble in water or insoluble in water. all insoluble salts, all insoluble salts, all insoluble salts, whether you're going to prepare an insoluble salts, so all insoluble, all insoluble salts are prepared by the methods or prepared by what we call precipitation method. Precipitation stroke double decomposition method. Double decomposition method. To all salts that are insoluble, they have a general method of preparation. That method is called precipitation or double decomposition method. So they are prepared or they are formed as precipitates. Now when we come to those salts that are insoluble, we have three ways of preparing them. Okay? Three ways of preparing them. We have three ways of preparing these salts. Say soluble salts. Salts, this is by precipitation, stock, double decomposition. Double decomposition method. Then soluble salts. How do we prepare soluble salts? Soluble salts are prepared by all methods. Soluble salts are prepared by methods such as methods involving prepare them by methods involving crystallization, or can use what we call direct synthesis. Direct synthesis, this one works for the liquescent salts, and most of the liquescent salts such as salts like anhydrous, iron perchloride, hydrous iron perchloride, iron 2 chloride, and non-2 chloride, magnesium chloride, zinc chloride can be obtained directly by heating the direct combination of elements. So that's what called direct synthesis for the liquescent salts. Those salts which can easily or which absorb water from the atmosphere and dissolve in it to form what we call solutions. Then methods involving crystallization. This one depends on whether the salt, yes, is soluble. Salt is soluble, and all reactions prepared when all possible reactants soluble, when all possible reactants are soluble. So a salt obtained when from its reactants, when they are all soluble in water. So that salt is prepared by the method called neutralization. For instance, we are going to prepare sodium sulfate. Sodium sulfate will be obtained from sodium hydroxide and then sulfuric acid. All these reactants are soluble in water. So that method would be neutralization, and then it involves what we call crystallization method. Then other salts like potassium nitrate, most especially sodium salts and potassium salts, even ammonium salts, all can be prepared by neutralization method. They are all soluble salts, but we use the neutralization. Why? All their reactants are soluble in water. But where all reactants are not soluble in water, then we have to react the acid with where all reactants are not soluble in water, then we react an acid with a metal, to a metal oxide, 3 a metal carbonate, 4 can be a metal hydroxide. Why? You have first of all obtain the solution of the salt, and then we carry out what we call crystallization method. Even these ones where reactants are all soluble can easily carry the reaction. You neutralize them, then you get the solution of the salt, and you carry out what we call the crystallization methods. For instance, for these methods, this can work for salts like iron to sulfate, copper to sulfate, zinc sulfate, zinc nitrate, barium nitrate, calcium nitrate, magnesium sulfate, can be obtained by reacting an acid with a metal, an acid with a metal oxide, an acid with a metal carbonate, an acid or with a metal hydroxide. You obtain them first of all in solution, and then we carry out what we call the crystallization. Come to the solubility of the salts. Solubility of salts. Solubility guidelines for any compound or solubility of what? Salts. Solubility of salts. This one helps us to know salts that are soluble and those that are insoluble, such that you can easily predict their method of what? Preparation. So I'm going to produce a table. Like this. Here I put what you call soluble, and here I bring insoluble. So any salt that lies on this line this way is soluble, these ones are insoluble. All nitrates are soluble in water. All nitrates are soluble. There is no any nitrate which does not dissolve in water. All salts derived from nitric acid are all soluble in water. Then that's one category. Two, we have all chlorides are soluble. All chlorides are soluble. But here, those ones that are insoluble shall have except there is silver chloride, there is lead 2 chloride, there's lead 2 chloride. Though all chlorides are soluble, but silver chloride, lead 2 chloride, even mercury 2 chloride is also insoluble in water. Lead 2 chloride dissolves only in hot water, and when you leave it to cool, it crystallizes out on chlorine. Then we have all sulfates. All sulfates are soluble, except, so you have said that any salt that comes this way is insoluble, except we have here lead 2 sulfate, lead 2 sulfate, barium sulfate, and we have calcium sulfate, which is calcium sulfate. Calcium sulfate is sparingly soluble in water. Can have all carbonates. All carbonates are insoluble, but here except these salts, the sodium sulfate carbonate, sodium carbonate, potassium carbonate, potassium carbonate, and then ammonium carbonate. Ammonium carbonate. But the rest of the carbonates are insoluble in water. So all these salts are prepared by the general method, that is precipitation method. Then those ones that are soluble, we prepare them by one, neutralization, or one, we say methods involving crystallization. Methods involving crystallization. And two, we use direct synthesis. Direct synthesis for the requisite salts. Most the requisite salts are prepared by direct synthesis. So in summary, can bring it as can bring it as like this. You can have a set like that circle. This one all inside is soluble. Outside is insoluble. So when you talk about nitrates, all nitrates are soluble. When we come to chlorides, you can say chlorides. But how does chlorides which are insoluble? There is lead 2 chloride, silver chloride, mercury 2 chloride. Those chlorides are insoluble. Then when we talk about sulfates, sulfates are all soluble. We have lead 2 sulfate is insoluble, barium sulfate and calcium sulfate, which is sparingly soluble. Then can have carbonates here, carbonates, but can accept sodium carbonate, potassium carbonate, and ammonium carbonates. So all those carbonates are soluble, then these ones are insoluble. So the method of preparation of a salt is depends on whether the salt to be prepared is soluble or insoluble in water. Soluble salts, we have said, they are prepared by methods involving crystallization. And those methods depend on one, whether all the reactants are soluble in water. For instance, when you are preparing sodium, potassium, and ammonium, salts, all the reactants that are used to prepare these salts are soluble in water. Therefore, we opt to use neutralization such that we obtain the solution and we carry out the crystallization. Another method where all the reactants are non-soluble in water. For instance, the oxide, carbonate, carbonate hydroxide, a metal. If all these ones are insoluble in water, so we opt to use an acid. We react them with an acid, we obtain the solution, and then we carry out what we call a crystallization method. So soluble salts are prepared by the methods involving crystallization. 2, we have what we call direct synthesis. Direct synthesis works most especially on 30% salts, and direct synthesis means direct combination of the elements. For instance, if you are preparing anhydrous iron 3 chloride, means that you have to heat iron strictly directly in dry chlorine gas. If you are preparing anhydrous iron 2 chloride, you heat iron in a dry current of hydrogen chloride gas. You are going to get magnesium chloride. You heat magnesium in chlorine. Zinc chloride, you get zinc in chlorine. That's direct combination of the elements. You want to get calcium chloride. You heat calcium in chlorine, or you burn calcium in chlorine to get those salts. Why? The salts are highly 30%. They absorb water and dissolve in it from solution. But so if we prepare them by methods involving crystallization, we cannot get them as crystals. They will have absorb much of the water. They will not form crystals. So they are the best method of preparing them is to obtain them in their anhydrous form. This is good. This time. Okay, sir. So that's enough for today. We shall meet again the next time. But stay safe at home. Keep the social distance. Don't move. Move where it is necessary. Coronavirus is real and kills. So stay home and stay safe. But treat hard. Thank you.